Welcome everyone. In this video, we will explore how to leverage LLMs, large language models, to do an important task or step in developing machine learning models called EDA, Exploratory Data Analysis. So this notebook will take you through an end-to-end process of EDA, and we'll be using OpenAI as LLM. In some of the future videos, we will discuss about LLMs and LangChain framework to orchestrate the prompts for us. So LangChain framework has an pandas agent which will help us convert our queries on the dataset into appropriate pandas API from the natural language interface. The prerequisite steps for this notebook is to sign up for OpenAI and get the API key. I've given the instructions here. You can go to platform.openai.com, sign in or sign up if you're not signed up before, and then you can click on the profile icon and get the API key, and then make note of the API key, and we'll also install LangChain and OpenAI libraries. This particular notebook link is in the description of the video. You can open the notebook using Google Colab. We will be using a data set to do the EDA, which contains samples of males in heart disease high risk region of Western Cape, South Africa. So this contains the samples of two sets of people who are suffering from CSD, who are not suffering. So CSD equal to 1 are people who are suffering from CSD, and CHD equal to 0, not suffering from CSD, and some of the other health parameters that has been captured for those patients, like systolic BP, blood pressure, the amount of tobacco consumption, LDL, which is the bad cholesterol, adiposity and obesity, very similar kind of information. Family history, if the person had a family history of CSD or no CSD. Alcohol consumption, type A behavior, age, quite important information, and we'll see how these features or variables are related to CSD. Some of the EDA steps that we'll explore in this notebook are getting a metadata about the data set, finding if there are any missing values in the data. We'll also do univariate analysis, like finding probability distributions, creating histogram and box plots to do outlier analysis. We'll also see if we can do a hypothesis test, a Ttest to compare distributions, and we'll also explore little deeper and do bivariate analysis, understand the relationship between two variables. So be creating scatter plot, correlation analysis, and heat map, and all that by asking the questions in a simple plain English language and see if an LLM can help us do all these tasks. So as a first step, we'll install required libraries, pip install LangChain and OpenAI, and then import required libraries. Here the two specific ones I want to highlight. One is the LangChain agents. So LangChain has an agent called pandas agent, pandas data frame agent, which is important here. And then the LLMs, we are going to use OpenAI. If any other LLMs like open LLMs, then also we can explore here, but we will do that in a future video. The first thing that we need to do is set the OpenAI key that we have taken note from the OpenAI site, and read the data set. So here I'm going to read the data set directly from the site into CSD_df and configure the LangChain agent. So at a high level, the LangChain agent, once a user asks a question, what the LangChain agent here is doing is creating a prompt which is an input to the LLM by augmenting the question that you are asking about the data set with appropriate instruction and context, which is very, very important. So that LLM can understand what we are trying to accomplish, and then it sends a prompt to the LLM. Here in this case OpenAI, and then LLM generates the appropriate code and sends back to the agent. So the LLM says, you want to accomplish this task, you want to get this information from the data. So here is the code, the pandas data frame code, which can be executed to get the answer. And then the agent runs that code on the Python REPL kernel and gets back the result and sends the response back to the user. But the response is also not sent as it is, that is generated from the Python kernel. So LangChain also sends the code result to the LLM for converting that response into interpretable text response for the user. So as a user, the response is in a descriptive format, in a simple plain English language, so that I can infer and understand it, which I think is a very nice idea here. So to initialize the agent, we can call create data frame pandas data frame agent and pass the LLM here OpenAI initialize it, and I am initializing OpenAI with the temperature 0 because I want a very deterministic response from the OpenAI. So you set to very high number like 1, especially when you are trying to generate a very creative response. But in this case, simply I'm asking a very specific question about the data. I want a very deterministic answer for that, so I'm setting it to 0. Then pass the data frame and verbose true to understand what the agent is doing. Just if you want to know which OpenAI has several LLMs and which LLM is actually using by default. So if you execute this, it says it's using the DaVinci LLM, which is I think based on GPT 3.5. So let's start the EDA. Let's ask first simple questions about the data. For example, how many rows and columns? So all you have to do is basically take this agent and pass the question to the agent. Here, how many records are there? So it says there are about 462 records. And if you look a little deeper, the LLM agent actually sends back a code saying that length of DF, which looks right, and which returns 462 and gets an answer. There are 462 records. We can also validate the answer by running data frame dot shape, which also shows 462. So this is the correct answer. This is of course a very simple one, and you can also ask like how many rows and how many columns are there, which it says there are 462 rows and 11 columns. And if you see deeper again, it actually sends df dot shape, the same that we did here. We can also ask can you sample like 5 records and display randomly. Just say sample 5 records and display. So it automatically does a dot sample, and you can see it randomly has taken 5 samples. The indexes are randomly taken, not in any particular sequence. So it's randomly showing 5 records from the data set. But this is about metadata. Let's ask little more complex question like, are there any missing values in the data set? So it basically says no, there are no missing values in the data set. So it has run this code df is null any, and it has found that the answer is false across all the columns, and it is able to interpret that and give a appropriate answer saying no, there are no missing values in the data set. Very nice. You can simply ask a question like this and it gets a descriptive answer like this. Now let's look at little univariate analysis probability distributions. Initially look at the frequency of the variables, like what are the unique values in the column CSD. Let's say we don't know what are the unique values. of any categorical feature, and it says the unique values in the column are 1 and 0, and you can see it rightly generates the code dot unique here. And let's say ask question, what are the frequencies of the unique values in the column CHD? So how many ones and how many zeros? What are the frequency of each unique values in the column CHD? So the frequency of unique values in the column CHD are for 0 302 and for 1 160. So it actually doing automatic the value counts for that particular column. Again, absolutely right in generating the code which gives the correct answer for that. If you execute that also, you can get it ourselves. And let's ask little more difficult question. If the value in CST column is 0, then it indicates the person is not suffering from CST. We're setting the condition and say, then how many persons are suffering from CST? And it says 160 people are suffering from CST. Right? So it has correctly interpreted, though I only given saying that 0 means not suffering, so it automatically understood that 1 means suffering, and it gives a correct answer saying 160 people are suffering from CST. And if I ask what is the probability distribution of persons suffering from CST, and then now the frequency, it's automatically converting, it's normalizing the data. If you look at the code it generates, it's normalizing the data which gives the frequencies, and so the probability distribution of persons suffering from CST is 0.653 for 0 and 0.346 for 1. It's very nice. And if you do value counts normalize, you can see 0.65 fraction of the sample is not suffering and 0.34 fraction is suffering from CST. So that's a probability distribution, at least in this sample. And if I ask little more tricky question like answer the query based on the following description. If the value in CST column is 0, that it indicates the person is not suffering from CST, then how many persons are suffering from CST who did not have any family history of CST? And I did not give any answer or any instruction about the column family history because the family history column is not encoded. It has information like present and absent. So I am assuming that it automatically understands the meaning of present and absent. And let's see what it answers. And it's correctly answering 64 people are suffering from CST who did not have any family history of CST. And if you do PD cross tabulation, he's actually put a condition here, people who are suffering from CST equal to 1 and family history is absent, right? That's a question I asked. How many people are suffering from CST who did not have any family history? And it appropriately converts that into absent. So 64 people who are suffering from CST and do not have any history of CST. And now let's convert this question to a conditional probability. Let's say what is the probability that a person with no family history of CST will suffer from CST? So this will be like what is the probability that somebody is going to suffer from CST? P of CST equal to 1, right? With the family history is absent. And if you look at that, it actually does a value count appropriately for that. So family history is absent and CST, and it calculates the probability for both people who are not suffering and suffering. And it says that the probability that a person with no family history of CST will suffer from CST is 0.23. Very interesting. We can also get the same information from the cross tab between CST and family history and normalize across columns. So here are the people who do not have any family history. So if you add these two probabilities, it becomes 1. And people are suffering, those who do not have a family history is 0.23, and it's correctly found. So you can actually understand tricky questions about the data and automatically calculate the frequencies of probability, a conditional probability, and give an answer to you. So you can actually ask questions in typical plain English language and get an appropriate answer for that. Let's dive a little deeper and see univariate analysis, which stands for analyzing a single variable at a time. And some of the important steps that we do when we do univariate analysis is like create a histogram to understand the distribution of the variable by bins or ranges, box plot to understand if there are any outliers are there, and bar plot. Typically histogram is used for numerical continuous features and bar plot for categorical features. So let's draw a bar plot to depict a number of persons suffering from CST. And CST is basically a categorical binary variable with having value 0 and 1, and we are asking to do a bar plot, so you should automatically count that and create the right plot. So if you see here DFCST value counts, so it's doing automatically the bar plot for us. So this is the frequency of people not suffering and suffering. This is absolutely fantastic. But this particular plot is we can further subgroup or stack by like a family history. So how many people suffering from CSD, and then we can also create subgroups or stack it based on having family history or not having family history. So let's say I ask a question a little more trickier here. Draw a bar plot to depict number of persons having family history of CST stacked by CST. So the first group should be created based on whether the person having family history present or absent, and then further stacked by CST. Okay. I'd be interested to know how this question can be asked in a different ways, but it could actually make out this question to create a stacked bar plot here. And you will see this particular group belongs to people who do not have any family history, and out of that the blue one contains people who are not having CST and having CST, and here people who have family history of CST and what's the distribution. So you can see that people who have family history of CST, the probability of is almost 0.5, so there's a high risk there. But here people who do not have a family history, the probability of getting CST, which is 1 here, is much lesser compared to not having CST. Very interesting observation here, and it could create the right plot for us just simply asking this question, saying that can you stack it by CST. Now let's create a histogram. So create a histogram on age using bins. So I can I actually asked a question called create a histogram on age, that's all, and it actually created bins a little differently, which makes sense, but now I want to control how the bins are going to be created. So I just asked a question like create a histogram on age using bins with 0 to 10, 10 to 20, and 20 to 30 years, and so on. That's all. I'm just basically giving an instruction, right? So it automatically expand that intention and automatically creates the bins or not? In fact, it does. You can see the DF age, hist, and bins range 0 to 100 with a step of 10. So here is histogram it creates. So 0 to 10, 10 to 20, 20 to 30, and so on and so forth. Very interesting. Of course, it would be nice if it can create a title X level and Y level automatically, but I think we have to ask this question specifically to augment the plot with appropriate information to look at to make the plot look more interpretable and nicer. Finding outliers. So if I just say, are there any outliers in terms of age of those suffering from CSD? Specifically, I'm asking for that population, the sample set who are suffering from CSD. So it's able to convert this into a describe, saying that df CSD equal to 1, this filters appropriately, and then this describe. And it says no, there are no outliers in terms of age of those suffering from CSD. This is something I not sure it's right, because the median value is 53 and IQR, of course you have to go and calculate the IQR, and I'm not sure how it calculated, but then I asked the question little more specifically to find outliers. For example, I ask here, are there any outliers in terms of age of those suffering from CSD? Find out using box plot. I just say box, you can say box plot. And it's able to understand that. So it's saying I need to find out if there are outliers in the column to CSD, and it actually did a plot for that, and you can see and there is an outlier here, and it's able to interpret that as well, and it says yes, there are outliers in terms of age of those suffering from CSD. That's very interesting, because I'm not sure how they actually did interpret the image, but it does. Now let's say we'll ask little more complex question about comparing probability distributions. So compare the probability distributions of tobacco consumption between those who suffer from CSD and not suffer from CSD using KDE plot, the kernel density estimation, typically probability distribution plot, very popular. Because I want to understand whether people who suffer from CSD typically has a higher tobacco consumption pattern compared to those who are not from CSD, and see if it can actually get that intention, interpret that intention appropriately, it does the comparison. And because I asked him to do a KDE plot, it actually does that. It created two groups now, CSD 0 tobacco and CSD 1 tobacco, and it does a KDE plot and overlap on each other. This is very nice. And but of course I still cannot understand which plot belongs to who, the blue and the orange. So I probably have to also ask in this case to create a legend for us. Alright, but anyway, it does the plotting nicely. My assumption is the orange one belongs to those suffering from CSD, and the blue one are not suffering from CSD. And if I want to go a little deep dive and understand or do a hypothesis test to know if these two distributions are very different, the average consumption, so I can do a hypothesis test, right? For example, here I'm asking, so let's say I will do a hypothesis test where my null hypothesis is the average tobacco consumption of those who suffer from CSD. Okay, that's basically the average tobacco consumption, the average of those who are suffering from CSD equal to 0 is same as the average tobacco consumption of who are suffering from CSD, not suffering and suffering. So basically the null hypothesis is the tobacco consumption of those who suffer from CST is same as those who do not suffer from CST. That's a null hypothesis, and the alternate hypothesis is not same. So let's ask this question. Interesting, but I tried couple of different ways to ask this question, and here I have to categorically ask him to do the t-test, which is fine. I mean, if data scientists are familiar with the concept, they can ask this question. So do a t-test for following hypothesis to test the following hypothesis, and I'm saying the null hypothesis colon the same question: tobacco consumption of those who suffer from CST is same as those who do not suffer from CST, and the alternate hypothesis is not same as those suffer from CST. And I asked this question to the agent, and interestingly, it does a fine job. It actually found out that it has to do a t-test and two sample test. This is very interesting. So it first separated both the samples who suffer from CST and not suffer from CST. It's calling it as a DF CST and DF no CST, and it takes those two groups and look at the tobacco consumption and does a t-test here, and I'm really impressed. It says that p-value of the t-test is very low, which is less than 0.05. This indicates that the null hypothesis can be rejected and the alternate hypothesis is true. That means tobacco consumption of those who suffer from CST is not same as those who do not suffer from CST. Very interesting. I could have done a one-tailed test to understand that also. Here, of course, from the t value statistics, you can see that the average consumption, because that's people who are suffering from CST as the first parameter to this, is definitely higher than people who do not suffer from CST. So a really impressive answer from here. And let's look at another variable, age. So compare the probability distribution of age between those who suffer from CST and not suffer from CST using KD plot. And here I am adding this additional instruction saying that create a legend. In fact, I misspell it, still it is able to understand that. X and Y levels for the plot. And if you see, it does create the KD plot with the legend equal to true, an X level, Y level, and it actually generates a legend here saying that the orange line belongs to the distribution of age who suffering from CST 0, 1, and the blue line belongs to the 0, not suffering from CST. And you can see the pattern here. So as the age increases, there is a high probability of getting CST compared to the other one. Now you can look at a bivariate analysis, comparing two variables, and most of the times we look at two variables, the correlation analysis and do a scatter plot. The common techniques here. So creating a scatter plot to depict the correlation. So let's ask a question like, so here in this question I did not ask to create a specific plot. All I said is show the correlation between adiposity and LDL using a plot to find out whether it can interpret the intention and rightly create the plot for us. And it did. It actually understood that scatter plot has to be done, and both are numerical variables. So it does it, and adiposity on X and LDL on the Y, and you can see the scatter plot. There's probably a positive correlation between them. And I wanted to also look at the correlation between these two for both the groups separately for CSD and no CSD. So ask a very specific question here. Show the correlation between adiposity and LDL across both CSD and no CSD categories using a plot. And it does that very cleverly. You can see that of course it does not create a legend here, but it separated both groups, one depicted by the blue and the other one is the dark color, and it shows the correlation. I think if you have to little augment these plots with labels or legends and all that, you have to specifically ask in the instruction, the request. And it looks very similar, and I have created category specifically using a scatter plot here with y as LDL, x as adiposity, and the third parameter hue is CST, and the same. So it's creating the correct plot here, though it could have added some more information to make it more interpretable, which is fine. Now finding the correlation among all variables, multiple. So what is the correlation between variables like age, adiposity, LDL, tobacco, and alcohol, right? Again, and it's able to automatically understand that and does a correlation matrix. It generates a correlation matrix, which is very nice. Because it's not very readable, the correlation matrix, it's always a wonderful idea to create a heat map around it. So I now little augment the question with one more set of instructions saying what is the correlation between these variables, and so using a heat map. Interesting. And it could understand that, and first it creates a correlation matrix and then put that matrix into the heat map here, and that's fantastic, right? It also creates beautifully. So very nice. So you can actually use this pandas agent from LangChain. Of course there are alternatives are coming up like pandas AI, but if you really want to query and understand the data set, you can always ask these questions in simple plain English language. You might have to experiment by changing the question a little bit and get the appropriate answer. Look at what the agent is actually doing. Is it just passing on the question to the LLM? Like I told you initially, it actually augments the question with appropriate context and instructions. So this is what the agent is actually sending to the LLM. And if you look at this is the placeholder of the question. So what a question is you ask is actually inserted, populated here, but besides the question, it sends a lot of this context and instructions to the LLM. So if you read little deeply, you are working with a pandas data frame in Python. The name of the data frame is in quotes df. You should use the tools below to answer the questions, and this is the tool, a Python cell. Use this to execute a Python commands. Input should be valid Python command. When using this tool, sometimes output is abbreviated. Make sure that it does not look abbreviated because it's code. And it's also asking him to, you should always think what to do before taking an action, and the actions that you should take is one of the actions, and here is of course so in fact the agent can actually choose between multiple tools, but here there is only one tool, which is a Python tool. And this is so an example of the result, how it should be written back. So that's very interesting. Of course I think you can also kind of little play around with this one, the template. We'll explore some of those things in future in detail. Some observations I found in this ADA while doing this EDA is sometimes you need to specify which plot you need exactly, which is not a problem. Sometimes it figures out automatically what plot to be created, and sometimes you have to explicitly provide that. The plots do not have labels, legends and titles and all that. You need to ask categorically to create those. It'd be nice if that can be given as part of the instruction, but then it does not know it is specific to EDA, so you may have to categorically ask to create. One more additional feature that could have made it a little better is to get a handle to the resulting data frame or plots. So data scientists may want to switch between code and LLM interface while doing the task. For example, if I ask, can you sample data and display? So besides display, if you can give a handle to the actual df.sample, that would be nice, right? Or here, while doing hypothesis test, if it can actually give me a handle to the Ttest results, of course, which of course I can capture that into some kind of response format, but it'd be nice if you can also get back the actual handle to the data frame or the results. So that's the end of the this tutorial. So in the future videos we'll explore a little more detail, dive little more, and probably explore some more LLMs or Pandas AI library. How does it fare compared to the LangChain agent? But you can also few of the questions that I have mentioned here, you can also try using the agent, like what is the probability that a person with no family history will suffer from CST, or create a heat map and with the divergent colors for positive and negative correlation. Just to show you, in the heat map, if the positive and negative correlations are shown into different colors, it will be very nicer to interpret that. So if you find something interesting, please mention in the comment of the video, or if you have any other questions that you want me to address in the future videos, please let me know in the comments. You can subscribe to the channel if you want to keep updated about new videos. So thank you and see you next time.